Okay, so the test is, again, it's on Monday. All of these different formulas, as we go through the review today, these are the different formulas that we will look at. I know the last section in particular had a ton of like random equations. None of that is on the test. It was just kind of a section to show you you can take calculus and you can do all of these different things. Where you will be tested is exponential growth and exponential decay. Remember exponential growth and exponential decay? It's the same idea. Here, K is called your growth constant. Here, they did not want to keep it as the same variable because one means growth and decay, it's going downwards. So they changed K to lambda. Lambda is a positive value. The negative is part of the formula because it's decay. Whenever you hear the words compounded continuously, that is the PERT formula. What half-life is exponential decay. And what happens is it tells you however much you started with, at the end of the half-life, you have half of what you started with. If you are doing elasticity of demand, it will ask for E of P. E is elasticity. It is negative P. You distribute that into the derivative of the function over the original. Then you fill in P, which is the price. If the value is bigger than 1, it's elastic. If the value is less than 1, it's inelastic. If they're asking for relative rate of change, it is the derivative over the original. Most of the time when it's relative rate of change, you will go ahead and also find percent rate of change. Once you find the answer, you turn it to a percent. Here are sample problems. How long? So what we're doing is right away we have to figure out what we're looking for. We are trying to solve for T because it's saying, well, how long would it take? How long would it take for an investment of $3,200 to triple if the interest is 16% and it's compounded continuously? Compounded continuously, that means we have the PERT formula. P stands for the principal. How much money do you have at the beginning? We have 3,200. E to the power of R. R is the interest rate. You change it to a decimal. 16% is 0.16. Then it's T. T is what we are trying to solve for because the question says how long until it triples. Triples means you would take your original amount of money and multiply it by 3. If I have 3,200, if I triple it, we are now at $9,600. What we're doing is solving for T. Ultimately, I need to cancel E. You cannot cancel E unless I get rid of this 3,200. Step 1, divide both sides by 3,200. This would cancel. E to the power of 0.16t equals 9,600 divided by 3,200 is 3. Cancel E. To cancel E, you take the natural log of each side. 0.16t is approximately, now you just plug that in. Natural log of 3, 1.099. Divide both sides by 0.16. 1.099 divided by 0.16. T is approximately 6.87 years. So you could even say, hey, it would take you about 7 years to triple your money. The key there was to know that it was compounded continuously, so it was the PERT formula. This is what the test is going to look like. Questions like that, not like crazy, crazy stuff. Okay, here is a half-life problem. Radium-226 has a half-life of 1,600 years. The half-life, that is how you can find lambda. So if I am starting with 1 gram of radium, E to the negative lambda, we do not know what that value is, in a time, the half-life is the time that it would take to break down into half of the original amount. In this case, it's 1,600 years. In 1,600 years, if we started with 1, it would be down to 1/2. If I divide by 1, negative lambda times 1,600 is negative 1,600 lambda equals 1/2 divided by 1 is 0.5. Get rid of E. take the natural log of each side. Negative 1600 lambda is approximately, natural log of 0.5 is negative 0.693. Divide both sides by negative 1600, and lambda, negative 0.693 divided by negative 1600, lambda is 0.00043. That is the rate that element is decaying. Now the question doesn't say, find your rate of decay. If it asked for that, you would be done, because that's what this represents. But what it says is after 5,000 years, so we have a time of 5,000 years, a given sample of radium-226 contains 8.2 grams. How large was the original sample? We are looking for P sub 0. We don't know what it was at the beginning. How much did we start with? E, lambda, notice that the value is positive. Because it's decay, we go ahead and we fill in a negative. So this would be our unknown value, e to the negative 0.00043 times t. In the problem, they said that we have been, or somebody has been monitoring the sample for 5,000 years, and at this time, we have 8.2 grams left. Does that make sense how I set that up? You want to know how much you had at the beginning. This is a number. You can plug that right into your calculator. So P sub 0, E to the negative 0.00043 times 5,000. This is 0.1165. All I did was plug this into the calculator and rounded. How would I find my original amount? Divide. So if I divide both sides, if I take 8.2 and divide it by 0.1165, P sub 0 is 70.386. So I'm just going to say it's approximately 70.4 grams. Now, keeping in mind all of these solutions, because we're rounding so much, we had to round for K. We had to round when we filled this in. It is all approximate. So if you are kind of working ahead of me, and let's say you had 70.3, great. If you had 70.5, great. It is about what I got. It just depends on how you round. So you might see a question like that. Number 3. Let's say you have $1,750 and you invested at 4% interest, compounded continuously. Compounded continuously, that's the secret word for, hey, it's PERT, okay? Write the equation that you could use to calculate the balance of the account. Well, the balance is going to be based off of time. That just means you fill in everything except for T. P, what is the principal? $1,750. E is a number. R is your interest rate. The interest rate is 4%. You always write it as a decimal, so 0.04T. That is an equation where we could figure out what the balance is as long as you knew how many years you plan to keep it in the bank. If you want to know what's the balance in 10 years, fill in a 10. What would be the balance if I kept it in there for 12 years? Fill in a 12. Then they want us to not only write the equation, but use it. What is the balance after 9 years? In the PERT formula, T is always time in years. This means T is 9. All you're doing is filling it into the calculator. 1,750 e to the power of 0.04 times 9. Close it, close it. If you're filling this into your calculator, make sure that you're getting the same thing. If you're not, let me know and we'll make sure that you are not making a mistake entering it. I got $2,508.33. Good? Good. I see a thumbs up. Okay, next. If f of x is negative 0.02x squared plus 60x, determine the relative rate of change as a percentage if x is 22. Now again, the first page, this will be available to you during the test. So if you're like, holy crap, I don't know, key word here is relative rate of change. It will say relative rate of change. Okay, what do? You take the derivative of the function, place it over the original. The derivative here, if I go ahead and take negative 0.02x squared, the 2 gets multiplied, and we have negative 0.04. Reduce the amount of x's by 1, so it's just x. Plus, the derivative of 60x is 60. That is the derivative. It goes over the original. That is the formula for relative rate of change. Now they said find the relative rate of change at a value when x is 22. So we just take the 22 and you fill it in for x. So what I do is I fill it in just the top and then just the bottom. Negative 0.04 times if x is 22 plus 60, I have 59.12. Now fill it into the bottom. Negative 0.02 times 22 squared plus 60 times 22, 1,310.32. Is that what you guys got? That's what I got yesterday too, so we'll trust it. Then in order to do this, you have to divide the two. 59.12 divided by 1310.32, it is 0.045. That is your relative rate of change. I know that whatever the value is, they didn't like tell us a story with this, but I know that it is increasing because this is positive. They want it as a percentage. So you go ahead and move the decimal twice. This would be 4.5%. I know it's increasing because it is positive. Here's another half-life problem. Potassium 42 has a half-life of 12 hours. When they tell you half-life, you can stop right there because that's what you need to find lambda. If I start with 1 gram of potassium, e to the negative lambda, it will take a time, 12 hours, for that 1 gram to break down into 1/2. If I divide by 1, it's not going to change anything. Negative lambda times 12 is negative 12 lambda. 1/2 divided by 1, you can keep it as a fraction. You could change it to a decimal. Take the natural log of each side because that will cancel e. Negative 12 times lambda equals, take the natural log of 0.5, negative 0.693. Go ahead and divide by negative 12. Negative 0.693 divided by negative 12, it's 0.05775. And again, it's easy to forget that lambda has to be a positive value because lambda goes with all of the decay stuff. The negative is in the formula. The actual value of lambda is positive. So I have that. Now we can read the rest of the problem. How long would it take? So we're trying to find T. That's what the question is. How long? How long would it take for an initial amount of potassium to decay to 1/8 of its original size? Do they tell us how much we're starting with? No. If they don't tell you how much they're starting with, be nice to yourself and just put 1 because the math is going to be the same. So if I'm starting with 1 gram, e to the negative lambda, negative 0.05775, t, how long would it take for 1 to decay down into 1/8? Does that make sense? They did not tell us how much we're starting with, so we're just saying, hey, if it's 1, what's 1/8 of 1? Well, it's 1/8. If I divide both sides by 1, it's not going to change anything. So I can even go ahead and say, all right, let's take the natural log of each side. Negative 0.05775t is approximately natural log 1 divided by 8. If you keep it as a fraction or you do it as division, just make sure you close the parenthesis after the 8. Enter negative 2.079. Divide both sides by the negative 0.05775. Negative 2.079 divided by negative 0.05775. T is, holy, I got exact. I got exactly 36 years. See, last night I got 35.9.
It's hours.
Oh, yeah, thank you. Make sure you check. I was just testing you. I'm just kidding. It is hours. Make sure that when you label, yeah, it goes with what the half-life is. That was my bad. It would take 36 hours. So if you had 1 gram in 36 hours, you would be down to just 1/8. That's how fast potassium would decay. After seeing a few questions, how do you feel about this test? Knowing you get the formulas.
Good.
Okay, not bad. Oh yeah, I have a lot of samples. I must have had fun making this review. I don't know, I just kept doing samples. Okay, the next part. Assume the demand function. What demand function means is how should you price an item? That's why it's P. How should you price an item to get to a set demand? You want to have the right amount, not too much, not too little. Q stands for quantity. So assume the demand function for a given product is Q equals 925 minus P minus 0.06 P squared. Find the elasticity of demand when the price is $40. Does this represent elastic or inelastic? Again, you will have access to the formulas. It is E of P because the E stands for elasticity. P is the price, so it's is it elastic or inelastic based off of the current price. The formula is negative P times the derivative all over the original. So I would take negative P times. We have to find the derivative of the original function. The derivative of 925 would be 0. The derivative of negative P is negative 1. The derivative of negative 0.06 P squared. The 2 will come out front and be multiplied, making it, why do I have, yeah, negative 0.12, and it would just be P. Now that's the top. What I would do, because you know what to do with parentheses, I would take this negative P and bring it in before you put the original on the bottom. So what I did here is I have my negative P, the derivative of the function, distribute this in. Negative times a negative makes it a positive P. Negative times a negative makes it a positive 0.12 P squared. That is the numerator. Now the denominator is the original, 925 minus P minus 0.06 P squared. This is the formula. Now to see if it's elastic or inelastic, you take P and you fill in 40 because it's $40. So if I go take the top, 40 plus 0.12 times 40 squared. I got 232 when I filled 40 into the top. Now fill 40 into the bottom. 925 minus 40 minus 0.06 times 40 squared. 789. Now divide the two. 232 divided by 789 is 0.29. This number represents the price of $40. If that number is bigger than 1, it's elastic. If it's less than 1, it's inelastic. 0.29 is less than 1, so this is inelastic, meaning it cannot stretch. If you increase the price, the revenue also increases. If you decrease the price, the revenue also decreases. They don't stretch, they do the same thing. I'm going to turn this or close this door. Otherwise, you're going to be listening to CNN 10. Okay, here is another one. If we have 250 bacteria and you place them in a culture, P of T, that is the number of bacteria present in the culture after T hours. Suppose P of T satisfies the differential equation 0.20 times P of T. This tells us that this is the rate that the bacteria is growing. So your derivative is how many bacteria do you currently have, multiply it by 0.2, and it tells you the rate that it is growing per hour. Okay, so the question, what is P sub 0? P sub 0 means at a time of 0, how many do you have? 250. That's all that it is. Find P of T. P of T is a formula that you could use to figure out the number of bacteria. So in order to do this, you have to realize, is this exponential growth or is this exponential decay? Is the amount of bacteria going up or down? Is this positive or negative? That's positive. So it's exponential growth. Exponential growth, if I look back at the beginning, that front page, if we're doing exponential growth, you start with P of 0. How are you starting? E to the power of K times T. That's what we're doing, is we're just finding the formula. We start with 250 bacteria. E, this is K. Because remember, the derivative is K times the amount that you currently have. It's 0.20 times T. That would be your formula. How many bacteria would be present after 24 hours? Well, T represents time in hours. T is 24. Go ahead and just fill it in. 250 e to the power of 0.20 times 24, it equals 30,377.6. We're not worrying about portions of bacteria, so I'm just going to say 3,378 bacteria. And again, it's approximate based off of how much we had to round. Okay, what is the growth constant? Growth constant is K. What value here is K? Yeah, 0.20. These are the type of questions where it is easy to like overthink, because you're like, is that all that it is? And during the test, I guarantee if there's something like this, some of you will come up to me and say, is that all I have to do? Yeah, that's all you have to do. A lot of these, they ask you the basics. You just have to make sure you understand what it's asking and don't make it too hard, okay? Last question. The size of a certain insect population can be given by this function. I know this is exponential growth, so we're starting with 300e. This is a positive value. That's how I know it's growing. That is my KT. T is measured in days. How many insects were present initially? 300. That is your P sub 0. Whatever the number is in the front, that's what you're starting with. Give a differential equation. So what would be the derivative? Well, the derivative would be whatever the growth constant is. It's K. This is 0.01 times P of T, or P of X. This just means how many insects do you have. The derivative is take the current amount of insects, multiply it by 0.01, and that tells you how many more insects you would get in one day. At what rate? Okay, we're looking at that derivative formula. At what rate will the population be growing when the population reaches 5,500? That means that we currently have 5,500 insects. If you want to know the rate that they're growing, you take 0.01 times 5,500. You just multiply the two. And when you take those two and you multiply them, 0.01 times 5,500, you would have 55 insects per day, because it's per unit of time. So when there's 5,500, every day you can expect 55 new insects. At what time? Okay, so solve for T. At what time will the population reach 2,800? Am I using the derivative or am I using the original if I'm looking for population? The original. We want to know if I'm starting with 300 e to the 0.01 t, when will 300 become 2,800? Solve for T. Step 1, divide both sides by 300. 2,800 divided by 300 is 9.3 repeating, so I'm just going to go 9.333. To cancel E, natural log of each side. 0.01 t is approximately. Natural log of 9.333 is 2.234 divided by 0.01. 0.01, 223.4. Time is measured in days. So about 223 and a half days from the beginning, when you had 300 insects, that's when it would reach 2,800. Last one. How many insects would be present after 17 days? Is that the original or is that the derivative? If you want to know how many insects are present, the original, right? Yep, the original. So T is just 17. We go up to the original problem, change T to 17, and you fill it in. If you plug that into your calculator, I ended up with 355.59 insects. So I just said, okay, about 356. Or you could put about 355. They are approximate. You're rounding throughout this whole thing. Then there is one problem where it's a graph reading. So you'll go ahead and look. Here we go. I'll just show you. So it's this one. It looks similar. This was one of the book questions. It's right out of the textbook, which is kind of nice. So what happened is there was a rod of steel, and it was 1,800 degrees. And what happened is they placed it into water that was only 60 degrees. The original function, f of t, is showing you what the temperature does. So you take that hot rod and you fill it into the cool water, and obviously it cools down. The rate that it's cooling down is your derivative. You're just answering questions by reading the graph. If you're looking for the temperature, it's the original. If you're looking at the rate, it's this one. So the whole test has 11 questions. We reviewed everything you will see except for the graph reading, and it is just reading the graph. Rest of the time, if you are going for the notebook check, here are the questions. 5-4 is 4 and 12. So 5.1, make sure you have 1 to 11, 13 to 22, 24, and 31. Then 5.2 would be 1 to 21 odds and 27. 5.3 is 1 to 9 odds, number 10, 13 to 23. 5.4 was 2 questions, and the test is Monday.